Now, using this form, and then let's find the slope. Then m equal to fx plus delta x minus fx over x plus delta x minus x here, right? So we just open and simplify this one, then it's going to be fx plus delta x minus fx over x plus delta x minus x. So this will be cancelled out. Then it's going to be fx plus delta x minus fx over delta x. So that will be the secant line slope using function rotation with interval between two axes here. So this form, particularly which is called different quotient. So this formula is really important now because we will apply this formula to define tangent line slope as well. Okay. And then also, many textbooks, because our textbook using delta x, but many textbooks sometimes or very often using delta x equal to h, which means delta x looks a little bit complicated anyway. Therefore, some textbooks generate as h. So delta x sometimes re-notated by h, and then I may use it too. So even though I'm using h later, so don't be confused. Okay. So now let's think about tangent line one more time. Tangent line means it intersects exactly one point here. Before we want to find out tangent line slope, I want to ask you one question. Do you think we can find the slope of the line if there's only one point available? Please pause this video for a second and think about this answer, and then after you think about it, please return the video. You may think about around 1 minute. So, what do you think? Is it possible to define slope of the line if there's only one point available? The answer is no, unfortunately. If we want to define the slope, then we need at least 2 points. So, only with 1 point we cannot generate slope of the line here. But unfortunately, this case, we have only 1 point available. But let's zoom in this part here. Zoom in this part. Then we may have something like this, and then the 1 point. So, why don't we maybe think about very close this to point like this. Then obviously we have 1 point and another point here, so we can find slope because two points are available. Now we zoom this one again, then it may be more like this, and then you choose 2 points again. Okay, so like this. So which means we are making zoom in more and more, which means try to make difference between x interval is almost 0. but not exactly 0. So whenever we approach to particular value, what kind of concept have we used? Yes, we used limit. As we discussed before, limit, which means we are estimating the value approaching very close to the value more and more, and the difference is almost 0. So last time, that's why we can input actually actual x value into the function, find the limit, right? So like that, we assume the difference between two x's almost 0. So here we define delta x, that's the difference between two x's. Just to define what if that equal to 0, okay? Or more likely approaching that value equal to 0. So we can make limit delta x approach to 0. And then now put slope formula, which is f x plus delta x minus fx over delta x. Then it is going to be tangent line slope value, even though it is not 100% correct because we're estimating, right? But it may be fine. Am I making sense? Yes. So this is the definition of tangent line slope. Okay?